Hey everyone, welcome back to my channel. The question that I'll be solving today is exponentiation from CSES sheet in the mathematics section. In this question, you will be given A and B, and you need to efficiently calculate a to the power of b and do it modulo 10 to the power 9 plus 7. You can definitely do it in a time complexity of big O of n, like it's big O of b, and you will be traversing from 1 to b and multiplying a and so on. But how can you do it in a time complexity of log n? Sure, let me show it. In this question, you need to calculate a to the power of b. So this is the iterative approach in which you can do by running a loop up to b and calculating a by multiplying a and so on and so forth. But in the log n time complexity, that is n as a power, or you could say log b. Let's say you have a to the power b you have already calculated. Now you can split this into a to the power b by 2, a to the power b by 2. If it is odd, then you need one more a, because if you are doing 5 by 2, it's 2. So 2, 2, and then again 1. That's why I'm doing one more a, because if it is odd, that is for a special case. Again, you can split this into a to the power b by 4, e to the power b by 4, so on and so forth up to you reach 1. Now, if you have already calculated e to the power b by 4, then you don't need to calculate this again. You can use this only to get e to the power b by 4. And now, if you have already calculated e to the power b by 2, then you don't need to calculate this again. So this follows only the height of a tree, and the height of a tree is log n. We know that. So that's the time complexity, because if you are having b, then you will be calculating b by 2, b by 4 up to 1. So you need to calculate this only, because if you are having a to the power b by 2, then you can multiply this with a to the power b by 2, and the resultant would be a to the power of b. Similarly for b by 4, so on and so forth. So this is the approach. Let me show the code and it will be more clear. Here this is the function which is taking x and y, and it returns x into y by doing the modulo operation. And this is the power function that we need to write for this particular question. In this question, x is basically a and p is the power. So we need to find x to the power of p. Now I'm doing the modulo operation, so it doesn't exceed 10 to the power 9 plus 6. Now, if p is 0, then x to the power 0 is 1, so I'm returning that. If p is 1, then I need to return that number itself, that is x. Now, I'm calculating x to the power p by 2, because if I calculate p by 2, then I can multiply z with z only to get a to the power of b. Like, I'm doing a half of the power, so it's x to the power of p by 2. And if I multiply z into z, so it will be x to the power p by 2 into x to the power p by 2. That will result in x only. But if it is odd, then we need one more x, because it will be x to the power p by 2, x to the power p by 2, and x. Z is the x to the power p by 2, so I'm multiplying this with z again to get our x. But if it is odd, then we need one more x to get our result as x to the power of p. And if it is even, then I need to return only x to the power p by 2 into x to the power p by 2. So that's it. I hope you like it. Thank you for watching.